Area under the curve by
Matthew.
Frankie.
Jerky.
Lee.
Just say your name. Why are we doing this?
Let's get straight into it.
That Calc.
Let's go on a journey to learn and love the area under the curve.
You would do it.
What is the area under the curve? Well,
Frankie, the area under the curve is the region between a function and the x-axis.
oh really? That's great. What else?
The area under the curve is calculated using integrals in a good old area.
That's amazing. Is it also a Riemann sum for chance?
Hot dog, you can also approximate the area under the curve using Riemann sum.
Keywords for this unit are function. This is a line on a graph. The slope is the rated change of a function. The graph is a two-dimensional plane that holds that function or line. The derivative, which is a function that represents the slopes of another function at a specific point. And the integral, a derivative. What? Integral, an antiderivative or the original function of a derivative, also represents the area under the curve of another function. Oh, what a transition. This is a good example of a derivative, right? So in the first one, you can see it's a rate of change over a period of time from one point to another point. But as you bring the points closer together, it represents the tangent line to that function at a specific point, which is the derivative because it's the instantaneous rate of change. Do you want to help me using area?
Yeah. If you are given a graph with the dimensions of length and width, you can find the area using regular area formulas, like such as length times width halves, etc. If you can't find the area under the curve using area, then you're stupid, but don't worry, there are other ways of finding it.
Whoa, okay, we're getting rid of that.
No, because sometimes
Alright,
if you
you're
don't have the
silly.
length
You're
in the
silly.
no, but if you don't have the length, if you don't have
Just get it, bro.
if you don't have
Just
like,
get the length of the width.
Alright, how to find the integral. Do you want to explain the rules below, Matthew?
You see these rules over here? There's a lot, but you basically have to memorize these rules.
That Calc.
How to use Riemann sum. Riemann sum.
Bruh.
So, Riemann sum is basically using rectangles to approximate the area under the curve. We use Riemann sum when we don't have enough information to use integrals, usually when a table is provided or there is no function. Because Riemann sum is an approximation, it could be an overestimate or an underestimate. This depends on which Riemann sum you use and if the function is increasing or decreasing. There are three methods for Riemann sum: left, right, and midpoint. For Riemann sum, you need to know two things: how many rectangles or subintervals you need to use, or which of the three methods, left, right, and midpoint, are you using. The left Riemann sum uses the top. Wait, what? Left Riemann sum uses the top left corner of a rectangle to approximate, while the right Riemann sum uses the top right corner of the rectangle to approximate, and the midpoint Riemann sum you use the midpoint of like the top of the rectangle to approximate the Riemann sum. Yeah.
That Calc.
Trapezoid rule is basically like Riemann sum, but instead of using rectangles to approximate, you use trapezoids. So basically, to use a trapezoid rule, you need to know how many trapezoids you need to use. Using the formula that we have provided, you can find the approximation using trapezoid rule. Real world area under the curve.
Real world.
I think it's my part. Oh hell yeah, this is my part. All right, sports scientist tracks the soccer player's heart rate at beats per minute throughout a game. His data is plotted on the graph with time on the x-axis and heart rate on the y-axis. The area under this heart rate time curve represents the total cardiovascular effort or work during the match, aka the number of beats between two times. Coaches and trainers use this to measure intensity, track fitness levels, or compare players' workloads. A larger area under the curve means more effort or higher intensity over the game.
That Calc.
Alright guys, I hope you liked the presentation. One final word from all the team members here.
Dragon.
I just want to say, stay in school.
Nick's got it next year.
The end, guys. Thanks for watching.